Thanks very much. As Robin said, Tim can't be with us today, sadly, so he sends his apologies. The good news is we still get the Wave Energy Scotland presentation. The bad news is you just need to listen to me for one more time. So as I alluded to in my earlier presentation, Edinburgh through SuperGen or SuperGen through Edinburgh, along with the ORE Catapult and Carbon Trust, have had a piece of working on the strategy and overall research coordination within the Wave Energy programme within Wave Energy Scotland. Before I start, I should also acknowledge that the Senior Research Engineer, Elva Bannon, is in the audience, so if you haven't engaged with Elva, make sure you do so in the drinks reception at the end of this presentation. So I would like to sort of give a little bit of a background to sort of the WES story, why it exists, what it is that we're doing, how we're doing it, and end up with some of the projects that have already started coming out of it, and what the next projects might be. So the Wave Energy Scotland story started just over a year ago with the First Minister at the time, Alex Salmond's Energy Summit, looking into where we were going to get future investment or future private sector investment in the wave energy sector, given that many of the large utilities had stepped back from their investment. And these are some of the quotes that came out of that Energy Summit, was saying that, that things like grid were sort of less important, that people were more concerned with getting the technology right, that a structured approach to developing this technology wasn't just a nice to do, it was absolutely essential that we had a structured approach. We had to bring this cold engineering industrial logic to regards to the steps that we took in the evolution of the technology, and that although we needed like a market signal to bring people, we really needed to get the technology right in order to make sure that we had an industry that we could have market pool mechanisms for in the future. So those were the messages that were given to the Scottish Government. And that's what led to Wave Energy Scotland being developed. And so these are some of the aims and goals. This is a summarisation of them. That it will support the development of subsystems, so making sure that we get all of the subsystems correct before we move to full-scale devices, so the only thing we're left with is systems integration as a technology risk. To make sure that we learn from other technology programs, make sure that we learn from other industries, making sure that there is efficient and effective technology transfer. People in the room will be pleased that Wave Energy Scotland has a remit to foster industry, academic collaboration, and at the same time making sure that we have a state aid compliant funding model to make sure that there is continuation of funding, not a start-stop funding progress. And to make sure that this is in alignment with what the private sector industry wants. We have an industrial advisory group to make sure that the projects that we're doing and the direction that we're going is the direction the industry and the OEMs and the private sector investment are most comfortable with, in order to ensure that they do come back to the sector in time. This is a schematic of how the overall program fits together. As you can see, we have subsystems that will be developed. There is a prioritisation exercise gone through to identify which are the most important technology subsystems that Wave Energy has to focus on. Many of you will know that the power takeoff has been the first call that Wave Energy Scotland has run. It's up and running. Many people in the room have projects operating in there. But it doesn't start from scratch. It has to capture the existing knowledge transfer from what's gone before it. We have done a great deal of work in this sector. The companies in Scotland, the companies in Europe have done a lot of work in this sector, so we're not starting from scratch. We want to build upon, so it starts with the existing knowledge. At the bottom of the graph, or the schematic, you can see that they have also novel device concepts as well. So to ensure that we haven't missed something, the second call that Wave Energy Scotland has done after power takeoff is novel device concepts. So asking for devices that make a significant step change to cost, reliability or performance of an existing device or a completely new device. And so as we run these calls, and there are other subsystems that will be developed, in time, and maybe it's in 3 years' time, maybe it's in 5 years' time, there has to be like a systems integration that bring these solutions, these toolboxes of like breakthrough technologies together into the leading technology that's going to give the private sector investors confidence that the sector is technically de-risked enough that it's happy to come back and make those investments. There are a number of funding options that Wave Energy Scotland has available to it. R&D project funding, collaborative projects, both mechanisms that they can use, but the mechanism that we are using most frequently is the pre-commercial procurement model, and that allows 100% funding to be given to companies. It's not like EPSRC or Horizon 2020 where you get a certain percentage. This will fund at 100%, and hopefully, if we get the stage gate mechanism correct and allow continuity of funding, so there's no start-stop with regard to the technical progress or the personnel and the knowledge that are involved in these projects, to take a technology or a device right through from an early stage or quite a late stage through to a technically viable and industrially commercial product. These are the type of sort of gate mechanisms that we have, or the stages of projects that we have. So we can start with, in the power takeoff, we either look for projects that were feasibility studies, looking at the early stage sort of concepts, through to concept optimization, small to medium scale prototype, through to medium to large scale prototype. And as you can see, there are different sort of values and time scales associated with the type of, the volume of funding that you would get at each stage. And we were quite strict with regard to making sure that they were very, very sort of, if we go back to the slide or the comment from the Wave Summit about having this cold engineering logic. And so in order to decide which area or which box or which stage you fitted into, there were a very strict set of metrics that gave you the eligibility, that had you the right level of experience, the right level of knowledge to go into like stage 3, or were you really in stage 2, to make sure that we weren't funding something sort of a large scale or medium scale prototype that really should have had more testing done at an early stage. And so making sure that this cold engineering logic and the approach that's taken is in the sort of the process that WES will use. There is no reward given for trying to jump stages. You know, in fact, it's impossible to jump the stages in WES, but we are rewarded that funding is available to do each and every stage fully, and if successful, you'll be able to move on to the next stage. So once you're in the programme with a successful technology, you're able to transfer all the way through the programme, assuming that you meet successful metrics with regard to the testing of your device, and those tests are successful and attractive with regard to the overall performance that you will be able to deliver to the programme. So this is the overall programme that we have in place at present. As you can see, we have the power takeoff and the novel device call. The power takeoff is up and running. 9 stage 1 projects doing the feasibility study, 5 concept optimization, 1 stage 3 prototype, so medium scale. And I'll say a little bit more about what those projects are. The novel device concept, we have 8 devices that we have started contract negotiation for, and hopefully there'll be devices come out of that and move into the next stage. Although we might find out that none of those devices meet the criteria to go to the next stage, in which case we'd have to start that process again. The other work that we're doing, knowledge capture, I said that earlier that none of this work is starting from scratch, that we need to sort of make sure that we're building upon the knowledge that is in the sector. So we do have a specific piece of work ensuring that WES captures the knowledge that's in the sector where it's at danger of being lost, to make sure it's available, that we don't duplicate and replicate any work in the future. I'll say a little bit more about the landscaping and technology transfer projects towards the end, just to sort of give you some context as to why we're doing that. So I said that we had the power takeoff projects, that they had been already awarded. And so I'll have quite a large number of projects, both at feasibility and at the later stages, and we have a very good balance across the programme of both advanced hydraulic systems, linear generation, electromechanical systems. We even have the electricity producing polymers that we heard David Forehand mentioning in the earlier presentation. So quite a good balance across the sort of device families within power takeoff, and at different stages of development. So we're looking at sort of step changes in performance, reliability, cost reduction coming out of those projects. So many of those projects now feel fully underway. And the first feasibility ones are only 6 months long, so Wes will be making a decision very soon with regard to the types of projects that are successful to move forward. Now, we've just announced, or Wes just announced a couple of weeks ago, what the winners of the novel device concept call was, and so this was to look at, had we missed something with regard to wave energy development, new ways of doing things. So either had to be a significant improvement to a device that was already out there, or a brand new device completely, so that we can look at sort of, do these devices have a significant benefit to us going forward? The only opportunity people had was to bid into stage one, looking at the early stages of device development. And so I'll just run through each of the projects to give you a flavour of the type of projects that will be being done over the next 12 months. So Jules Energy, Nick Wells was here earlier, I'm not sure if he's still here, is looking at a wave train version of the sloped IPS buoy. Sloped IPS buoy has been around for a while, but this is a novel way of linking them together into into a train of 3 devices, and the benefits that are associated with taking that approach. AWS Energy have taken a point absorber wave buoy and looking at novel systems within the tail tube to significantly improve the performance. Quotient, the company that's been reformed from some of the Palamas staff, looking at novel materials and novel approaches to the structure of a Palamas type device. Albatern, I know that some of the Albatern research students are here today, looking at novel ways of improving the electromechanical hydraulic power takeoff and the interaction between the capture buoys on the Albatern device. Checkmate, I don't believe that there's anybody from Checkmate, am I wrong? No, looking at the Anaconda technology, so technology that's been around for some time, perhaps lacked the ability to have a suitable power takeoff, but this project will hopefully sort of answer the questions with regard to whether that's a viable technology to take forward. I hope somebody from Zyber Renewables is in the room, because I don't quite know how to describe this technology and how it operates, but I do see a hand up in the second row back here. So for those interested in the Zyber technology, then please engage with the Zyber representative here. So we'll be interested to hear how your technology operates and what significant benefits there are there. 4C Engineering have looked at, or going to look at a pontoon approach there, looking at what the benefits can be taken from that. So that will be very interesting to see what the advantages are of taking that particular approach. And last but not least, Motion Energy, looking at a hinged float converter, sort of, to me, looks like sort of one single joint of a Palamas type technology, but with a very different structure. So it'll be very interesting to see what the advantages are of that particular technology. And so each of these technologies will have to go through an exam question at the end of their sort of development within the project with regard to going through a set of C states so that we can judge one against another with regard to their performance, but not just their performance, looking at what the concept engineering will be. That is this something that, although it performs hydrodynamically very well, is this something that we believe we can take forward into an engineered, reliable, cost-effective device. So I mentioned earlier when I looked at the overall programme, I had the two calls that had been launched. There is an open question with regard to what the design of the next call will be. Our advisory board, going through a prioritisation, have indicated that materials and coatings, forces and stresses, manufacturing processes, forecasting methods for control system themselves, and knowledge transfer from other sectors are all areas that are of interest to Wave Energy Scotland to focus on for the development of the wave sector. We're not ready to move into a call with regard to what actually would be asking for in each of those particular areas. So what we will launch within the next couple of weeks are invitations to tender for landscaping studies in order to do research as to what we would like to come out of each of these areas, and we can take those results with regard to, for instance, in materials and forces and stresses, with regard to if we decide to open a call on structural materials, what's the type of things that we're asking to be done within that call. So rather than launching into a call immediately, doing a piece of underpinning research and landscaping in order to identify and to be able to focus in on the types of things that we would like from each of those calls. So keep your eyes open for that and the future calls that will come out of that. So this is the last slide. Hopefully I've given you an overview of the sort of the high-level objectives for Wave Energy Scotland and how it started. We've identified the initial priority areas that we've already started the 2 calls on. We will do the landscaping to identify the future calls, and that will happen very soon to have calls sort of probably spring next year. But hopefully what you are identifying is that this is really a new paradigm with regard to wave energy development. It's quite a significant and different approach that Scottish Government have taken there, and I think that there are significant collaboration opportunities from the research that we've heard about throughout the course of the day and the future work that's required in the development of the wave energy sector. Thanks very much.
This production is brought to you by the University of Edinburgh.